So here is day 2 of Unit 8, where we're going to talk about what's called the nature of the roots. Specifically, the nature of the roots. I don't know if you recognize this. I know it's been a long time. The quadratic formula. In the quadratic formula, underneath the radical, this thing is what we call discriminant. Did I spell that right? Discriminant. Looks good. All right. Don't worry, it's not a spelling test, thank goodness. So the discriminant is essentially what determines how the roots will look, okay? So, for example, if you take a square root of a nice number underneath here, like 9, you're going to get plus or minus 3. If you take the square root of a number like 12, that's not a perfect square, you're going to get a radical. Okay, so the discriminant underneath the radical here describes the behavior of how the roots will appear. And that brings us to the nature of roots and 4 different types of quadratic graphs that we're going to consider. Now, when we look at a quadratic equation like example 1, where we have y equals x squared minus 6x plus 9. The first thing we want to do is get it in standard form. Notice this is in standard form. Okay, so I should write that. Standard form. Okay, and we want to identify our a value, which here is 1, our b value, which is negative 6, and our c value, which is positive 9. When we do that, the discriminant, right, d, which equals b squared minus 4ac, we're going to plug those values in. So d equals b squared minus 4 times a times c, always with your parentheses. And let's change color here. B is negative 6, 4, 1, and 9. And that looks like it's going to give me D equals 36 minus 36, or 0. Now, when I graph, where did my Desmos F go? Here we go. When I graph the graph y equals x squared minus 6x plus 9, I get a nice graph like this. Now this nice graph, notice it has 1 root. That's what's always going to happen when you have a discriminant of 0. So, whenever you solve for a discriminant and your graph or your discriminant comes out to be 0, you're going to have what we call 1 tangent root, or just 1 real root. So this thing right here means 1 real rational root. Okay, and I'll graph it here. It looks like this, where you only touch 1 time. So that's one case. Okay, now when you have a graph of something like x squared plus 1, so the first thing we want to do again is we want to go in and identify, again, notice that this is in standard form, where the b value is 0, okay, a is 1, and c is 1. When I plug in my a, b's, and c's into my discriminant, looks like I get 0, 1, 1. I get a discriminant, let's just be consistent here with the coloring. My discriminant equals negative 4. Interesting. A negative. Where is that negative? That negative is under a radical. So when I go ahead in my Desmos app and I graph x squared plus 1, what do you notice about that root? That root never even touches the x-axis, aka it doesn't have one. So we call that imaginary. Okay, we call that an imaginary or no real root or roots. Okay, so those are what we call imaginary. And those are just graphs that don't touch the x-axis. Okay, they could be above, they could also be below. They could be something that looks like this, right? It could be an upside down parabola. But as long as it doesn't touch the x-axis, then
I'll check back with you in 15 minutes.
All right, so somebody's getting in trouble. So with x squared minus 9, for example, number 3, you want to make sure that, again, your parabola is in standard form, where the coefficient in front of A is 1, the coefficient in front of B is 0, and the constant term is negative 9. We're going to take those values and we're going to plug them into our discriminant. And D equals B squared minus 4 times A times C, where B is 0, A is 1, C is negative 9. When I solve that, I get D equals 0, negative 4 times positive 1 times negative 9 is positive 36. Well, positive 36, that is a positive perfect square. Okay, and it's important to identify that that's a positive perfect square because think again, where does it sit in the quadratic formula? It sits underneath a square root. And if it's underneath a square root and I take the square root of a perfect square, I get a nice, real, rational number. So what that means is I get 2 real, rational roots. And we can verify this in our Desmos app here, where we've got, let's take this out of here, minus 9, and I have 2 real, rational roots, negative 3 and positive 3, right? So, we can sketch that out, make sure that we have a nice, so that's negative 3, positive 3. Okay, and the last type that we're going to consider is something like x squared minus 2x minus 4. Again, notice it's in standard form. Once it's in standard form, we can pull out our A's, B's, and C. We can then plug that into the discriminant formula, right? That's just what's underneath the radical in the quadratic formula, where our discriminant equals B, which is 2 squared minus 4 times A times C, negative 2, 1, and negative 4. The discriminant equals 4. 4 times 1 is negative 4 times negative 4 is plus 16. So my discriminant equals 20. Now that's a positive number, okay? But it's not a perfect square. It's positive, but not a perfect square. And that's going to have an impact, okay? So we're essentially going to have a radical underneath the square root, right? Or excuse me, we're going to have a number left out of the square root. We're not going to be able to simplify the radical all the way. So what we have here is as soon as I look at that root, come on, right? I have one here. Hey, that's not a nice number, right? That's not like a -3 or a -4 or even a -2.5. It's a ugly number or an irrational number. Desmos is rounding it at 3 decimal places. However, when it appears like that, that's what we call an irrational number. So that means we're going to get 2 real irrational roots. Okay? 2 real irrational roots. And what does the graph look like? Well, it looks something like this, where it does hit, but at an irrational spot. Okay? So again, before we can pull the values for A, B, and C, just want to quickly reiterate that we have to get everything to one side. Okay? So, for example, if you have x squared minus 3x plus 9 equals, oh, I don't know, minus x plus 5, right? What you really want to do is you want to get all of your terms to the side where x squared is positive, okay? So you're going to want to add x and subtract 5 and subtract 5 and get x squared, what is that, minus 2x plus 4. And then from here, right, now that you're in standard form, find your A, B, and C. Okay? So after this video, go ahead and continue with the Nature of Roots homework assignment, and have a great day.